Hi, I'm KSpoerl, and today I'm going to be talking about the signal receiver inside a radio system. So to do this, we're going to be analyzing each of the key components of the system and determining each of their functions, as well as how each plays a role in transforming the signal that you receive over the air into a signal that can actually be output by this radio system, either stored or broadcasted. So first, a small breakdown and a synopsis of all of these key pieces. We have the antenna right here, which is what picks up the frequencies coming over the air that might have been transmitted by a radio tower or station. We have the diplexer right here, which is what determines whether the radio is currently transmitting data through the antenna or receiving data through the antenna. And for this instance, we're going to be looking at the diplexer as it's always receiving data. Then we have the bandpass filter and low noise amplifier. This bandpass filter is used to isolate the signal, and the low noise amplifier amplifies the signal while trying to not amplify the surrounding noise, so we get a clearer signal. After this transformation takes place, it goes into this mixer or demodulator. So what this does is it takes the baseband signal that we want to receive out of the carrier signal that was broadcast by a radio tower or station. After this process occurs, it goes through an amplifier to amplify the signal more, and then a low pass filter to try and kill the outside frequencies that we don't want. So the repetitions of the frequencies. All right, so the first device that we're going to go more in depth on is the antenna. So the antenna is designed in a very, very specific way, and it has a specific wavelength that the antenna is designed to be, so it can receive signals at desired frequencies more efficiently. So how does it do this? Well, the wavelength is determined by your C over F. And your C is determined by the permeability and permeativity of the actual substance that the board is placed on. So knowing these factors, we can determine what wavelength or what length the antenna needs to be so the frequencies that it wants to receive can be optimally gained. So for this specific schematic, the length of this antenna is about 470 millimeters. So that's designed for the 315 megahertz that this system is supposed to be receiving on. So it's optimized for that general frequency. Now, when transmitting data, this system will transmit it, like the radiation patterns for the system will be different depending on which way it's coming out of the system. So it will be heightened at points where it's normal to the antenna's positioning inside the system. Now that we've talked about the antenna, we should talk about the bandpass filter. So this bandpass filter is very important because what it does is it isolates the signal that we want that was given to us by the antenna and cuts out all of the other signals that are being transmitted that we don't want. So what this bandpass filter will do is it will give you a high gain at this frequency that we want, and it immediately falls off at frequencies we don't want. So to get a high gain, we want a high R out. And to get a high R out, we have to do some special positioning of inductors and capacitors in here. So to amplify at a specific frequency, F naught, it resonates at 1 over the square root of your inductance times your capacitance, if they are put in parallel like they are here. So we can specifically designate an inductor or capacitor or change them out to determine what frequency we want to isolate this, what frequency we want to isolate with this bandpass filter. So it'll boost the R out and gain at that point depending on your values of L and C. So now that we know how to isolate the signal, we want to learn how to demodulate the signal. So if we look right here, this is the signal coming in through the antenna before it's demodulated, and this is how it appears after it's demodulated. So when you look at it before it's demodulated, you see that the signal is trapped within this carrier frequency that it was transmitted on, and this frequency is mostly around 1000 kilohertz. Now, you wouldn't be able to hear that if it's coming out of a radio, so you would want to scale that down to baseband frequency, which is exactly what this demodulator does. So it'll move this by subtracting the carrier frequency out of the system, you're able to move this frequency down to baseband and move it up to 20,000 kilohertz. So you only want the signal at baseband. So in the next segment, we use a low-pass filter. And what that low-pass filter will do is it will kill that repetitive frequency at 20,000 kilohertz and just leave you your signal that was originally transmitted from the radio tower. So overall, what this system does is it takes information through the antenna, it isolates the information, it takes that information and it eliminates the carrier frequency that was originally transported on, and then it isolates that signal even more by eliminating repetitions of that signal at higher frequencies. And then finally, you can, with that baseband signal, either store it or transmit it through the radio. You could hear music. So this is how this is done. Thank you.